All right, welcome to 7.3. You've seen systems like this before, so I'm going to give you a couple of examples and then an application. Welcome back to school, in quotation marks. I'll be posting stuff to the Moodle pretty regularly. I'll try to have it chock full of stuff soon, and we'll be doing homework through WebAssign just like normal. So now we're solving 3 variable systems instead of the 2 variable systems that we saw right before break. So if there's 3 variables, we need to have 3 equations. You can see the second equation has already eliminated z, so we'd kind of like to eliminate z again, and then use those 2 equations to find either x or y. So we'll put these 2 guys together. In order to do that, we've got to do some eliminations. We've got to multiply this top guy by -5 and this bottom guy by 3. That way I'll have a coefficient of -15 and 15 for z, and I'll be able to get rid of those. So that gives me -5x plus 10y minus 15z equals -45, and 6x minus 15y plus 15z equals 51. So now I can eliminate my z variable. I get x minus 5y equals 6. Now I can take this equation and combine it with equation 2. So I've got -x plus 3y equals -4. We can see I don't even have to eliminate anything. Well, I don't even have to manipulate it because I can already eliminate stuff. So the x's are gone. I get -2y equals 2. And I find that y equals -1. To save myself some work, I'll just plug that into the second equation. -x plus 3 times -1 equals -4. So we've got -x minus 3 equals -4. Add 3 to both sides. -x equals -1, so positive x must equal +1. Then I'll plug x and y into one of my original equations. We'll do the first one. So if I do that, I've got 1 minus 2 times -1 plus 3z equals 9. So that's 1 plus 2 plus 3z equals 9. So that's 3, subtract 3 from both sides. I've got 3z equals 6. So z equals 2. You can write it like that. X equals 1, y equals -1, z equals 2. You might also see it as kind of a ordered triple. So the x goes first, the y goes second, and the z goes last. Here's a similar example. This time we've got 3 equations with 3 variables in each one. It's set up pretty nicely to either eliminate y or z. We eliminated z last time, so let's eliminate y this time. So first I'll put the 2 equations at the top together. That gives me 3x plus 2z equals 9. And then I'll put the last 2 together. That gives me 5x, oh, that's even better, equals 5. So, x equals 1, didn't even have to do much work. We'll plug that into the next guy. So 3 times 1 plus 2z equals 9. So 2z equals 6, z equals 3. Pick any one of the first 3 equations to plug x and z into. We'll pick the first one. So 1 plus y plus 3, 3 equals 6. So y must equal 2. One last problem. This is kind of an application. So this time we're given 3 points. We want to find the quadratic equation whose graph passes through those points. We need 3 points, because if I just had 2 points, let's say I had these 2, then I could draw a lot of different quadratics. So this is why I need 3 points. That's going to create a unique quadratic. So remember, the equation for a quadratic is y equals ax squared plus bx plus c. So I've got 3 different sets of points. So I've got an x and y for each, for each point here. So I'm just going to plug those in and get three different equations. So the first guy will be 3 equals a times negative 1 squared is 1 plus b times negative 1. Let's clean that up a little bit. So that's a negative b. So a minus b plus c. That's my first equation for my first point. My second equation, x is 1 and y is 1, so 1 equals a times 1 squared is 1, plus b times 1 is plus b plus c. That's from my second point. And my third point, x is 2, y is 6, so 6 equals 2 times x squared, so that's 4a plus 2b plus c. So now I'm going to solve it just like I did before. I'd like to eliminate some variable, doesn't matter which one. It looks like probably B or C will be the easiest. It's always up to you which order you do it in, doesn't matter to me. Any order will work. So the C's have no coefficients going on, so let's do the C's. We'll multiply the second equation by negative 1 and combine it with the first. Some of you maybe can get away with doing it in your head. Some of you might need to write it out. Goodness gracious. Need to write it out to keep things straight. Okay, so here we go. So I get to eliminate my C. I don't know what's happening with my Apple Pen here. We'll try to survive though. Oh gosh. So I get 2 equals negative 2b. So b equals negative 1. I'm going to go ahead and eliminate C again, even though I already have B. So I want to get an equation that has B in it. So we'll do the first and third together. So I'll multiply the third equation by negative 1. So the first one stays the same. The third one becomes negative 6 equals negative 4a minus 2b minus c. So again, I can get rid of c. I get negative 3 equals negative 3a minus 3b. And remember, we already know what b is. So I'm going to plug that in down here. So negative 3 equals negative 3a plus 3 when I plug the negative 1 in for b. So negative 6 equals negative 3a. Sorry about this handwriting, folks. So divide by negative 3a equals 2. I'm guessing my pen needs to be charged. Hold on. Okay, we're back with hopefully a charged pen. So 2 equals a. Oh yeah, we're in business. So now I know a and b. I need to find c. Go back to any one of the original 3. We'll do the second one because it's nicer. 1 equals 2 minus 1 plus c. So 1 equals 1 plus c. Subtract 1 from both sides. C equals 0. Again, we can write it like that, or we can write it as an ordered triple. So 2, negative 1, 0. So remember, they wanted us to write a quadratic equation. So we really just found a, b, and c. So our equation is y equals, a is 2, so 2x squared, plus b is negative 1, so minus 1x, plus c is 0, so this is the equation that goes along with these 3 points.